All right, so what we're doing here is two-way frequency tables again, and just doing phase 2 and getting good at what we've already been practicing. So the two-way table shows the number of weddings in Ohio from the year 2018 and 2019. A wedding from 2019 is randomly selected. So it has to be from 2019. What is the probability the wedding was in July? So from 2019, there was 3,230 weddings, and 371 of those was in July. So you could have this fraction, or we could plug it into a calculator and get some decimal, 0.11486, or you could even say 11.486%. All right, fraction, decimal, percentage, all the same thing, just represented differently. All right, what was the probability a wedding was in 2018 or, so this is a huge word right here, or in February? So what we got to do is first we need to find, so let me do it like this. The probability of a wedding being in, we'll just put 18 for 2018, union or February. It's going to be the probability it was in 2018 plus the probability it was in February. But then we can't double count. We can't do the 2018 February weddings twice. We can't. So first off, how many total weddings was there? We got to calculate that number. And there's 6,732. All right. So in 2018, though, it was 3,502. All right. So it's going to be 3,502, the amount of 2018 over the total, plus the amount in February, which again, I don't think we have that exact number. We got to calculate it really fast. So 714. Okay, then we got to minus the ones we double counted, which 393 appeared in both of them. All right, and then we just add those numbers straight across. 2 plus 714 minus 393. And then you just keep what's on the bottom. All right, and that's it. All right, so this was a good OR problem. All right, out of the 6,732 weddings, 3,823 were in 2018 or in February. All right, now right here, a survey was conducted to determine whether a group of 9th and 10th graders preferred otters or beavers. Fun fact about me, I like otters, I like beavers, but clearly otters are the best. All right. Beavers are pretty freaking cool, but it's no debate. Otters are the best. All right, but let's see what 9th and 10th graders think. All right, the results are shown in this table below. Based on the table, what is the probability that a student preferred otters given that they were in 9th grade? All right, so realize something, I could have talked about this in the other one, is totals. No totals are given. All right. So do we need to know every single total? No, but let's just go ahead and compute the totals just so it's going to help us interpret our information. And this is something you need to watch out for when doing the air test. It's not necessarily going to give you the totals, and it can kind of maybe trick you. I don't know if they're intentionally trying to trick you or it was unintentional, but nonetheless. So I'm just filling in the table. All right, so there's all the totals. All right, so based on the table, what is the probability that a student preferred otters given that they were in 9th grade? So it was given that they were in 9th grade, so it had to be this row we're looking at. And out of the 104 9th graders, 83 preferred otters. That's it. That's the answer. Or you could do it as a decimal. 0.798, so about 79.8%. All right. Then we got this one right here, another two-way table. The Ohio State University determined that the number of students favorite sports and majors. Some of the results are shown. So this one right here, what we got to do is just fill in stuff. Okay, I'm just going to start right here with the totals. You can figure out this number first. All right, just do 20,000 minus 8,200 minus 8,100, and we get 3,700. All right, next I'm going to figure out this number right here. All right, it's a slow process, but we will get there. That's going to be 9,900. All right, what I'm going to do now is this one. So again, you don't even have to watch this video. Hopefully you have the capabilities of determining these numbers yourself. Sometimes you don't have to go the specific order I'm going in, but it can help. There's a lot of people surveyed in this. Got a lot of information. All right, so these are all the results shown. That took a while, some awkward silence, but nonetheless we finally got there. All right, so now let's answer these follow-up questions. All right, so we filled in the table, now let's answer these follow-up questions. So what is the probability that you randomly pick a student who's a science major whose favorite sport is football? All right, so you just pick some random student. All right, so this is saying out of 20,000, you specifically pick a science major whose favorite sport is football. Oh, that's a lot of people. All right, so that's it right there. Get it as a decimal, 0.325 or 32.5%. Okay. Given that a student is a math major, so now in this one right here, we're focusing on only math majors, all right, that their favorite sport is baseball. So this would be out of the 8,200 that their favorite sport is baseball, 7,000. All right, that's how you interpret it. They had to be a math major, so that would be about 0.854 or 85.4%. So out of the math majors, 85% of them favorite sports baseball. And then this one right here, what is the probability that a student is an English major or they like basketball? So this is what you're going to do right here, probability that they're an English major, or we'll put K for basketball so we won't confuse it with baseball. All right, so it's a probability they're English major plus the probability basketball minus the English majors that like basketball. We can't double count them. All right, and then we'll just do one giant fraction. It's all going to be over 20,000. So English majors, how many English majors are there? There's 3,700 of them. How many basketball fans are there? 2,100. And English majors whose favorite sport is basketball, well, we double counted those twice. That's 1,000. All right, and just to be clear, what I mean by double counting is like we have English majors. All right, so the 900, 100, 1,000 all adds up. And something might be a little bit wrong with this table, but it's too late now. We'll just move on. All right, and then we have this down here. And then notice how we have to subtract the ones we double counted. All right. So it comes out to 4,800 over 20,000. Which is about 24%, exactly 24%.